All right, repeated measures ANOVA. This is worksheet question 1. All right, so if you're looking at the chart on the worksheet, you'll see that there are 3 groups. All right, the only difference between this and a one-way ANOVA is the groups use the same participants. So the first thing you want to do is get DF between. That should look familiar to everybody. It's K minus 1, 3 groups minus 1 equals 2. So I label this between groups. Your textbook in this chapter will label it between treatments. So between groups, between treatments, they can be used interchangeably. Then we get DF within groups, which is also should be familiar to everybody, which is the sum of the DF per group. So there were 6 per group. So 5 plus 5 plus 5, 15. All right. Then we get DF between the subjects. So that's n minus 1 of one group. So there's 6 participants per group. So 6 minus 1 equals 5. And then you get the DF error, which is DF within groups, which is 15, minus DF between subjects, which is 5. Then you get 10. So now you have the 4 degrees of freedom. Next, you have to complete sum of squares. The first sum of squares you should do is sum of squares total. That's the sum of x squared, which is given, which is the sum of all the scores in the study, minus the gram mean squared. You'll see it labeled as G in your textbook, but G means gram mean, so I'm labeling it as GM. GM squared over N total, which is the total number of scores in the study, not participants. We know that there are 6 participants in this study that get measured 3 times, so N total in this case is 18. So you do the sum of x squared, which is 184, minus the gram mean, which is 48. So 48 squared divided by N total, which is 18. You get 56. SS within, right? That's simply the sum of squares per group added up. So 8 plus 10 plus 10 equals 28. Those are given to you, so you just add them up. The next, you want to get the sum of squares between groups. Best way to do that is take the sum of squares total minus the sum of squares within. 56 minus 28 equals 28. The next is sum of squares between subjects. So you'll see a new symbol, P. P is the sum of each participant's score in all 3 phases of the research study. So you'll see the P scores given. So it's the sum of P squared over K minus the gram mean squared over N total, again, which is 18. So you have to do each P squared divided by K first. So if you see here, 6 squared divided by 3, 12 squared divided by 3, 9 squared divided by 3, etc., etc., etc. Do this function first by itself, and do this function by itself, which is the gram mean over N total. So if you go down to the second line here, you'll see 36 divided by 3, this, and then the final numbers for these is right here. The sum of the P squares divided by K is 138, and the sum of gram mean squared over N total is 128. So 138 minus 128 equals 10. Then you want to get sum of squares error, which is SS within minus SS between subjects. So that's 28 minus 10 equals 18. 28 minus 10 equals 18. All right, next you're going to get MS between groups, again, or MS between treatments, same thing. So you take SS between over DF between. 28 divided by 2 equals 14. Then the denominator of this is going to be MS error. So you take SS error over DF error, which is 18 divided by 10, which equals 1.8. Your F critical, you get it the same way that you got it on one-way ANOVA. The only difference is you're using DF error instead of DF within. So you're doing DF between groups, which is 2, and DF error, which is 10. Go to the chart, it's 4.10. Get your F obtained, MS between groups over MS error, 14 divided by 1.8, 7.78. F obtained is larger than F critical. We know we have a significant result. Last step is eta squared, which is the effect size. It measures the same thing that R squared measured on t-test. The proportion of variance explained by the treatment effect. And that's SS between groups over SS between groups plus SS error. So 28 over 28 plus 18 equals 0.61.